Hey, welcome back. This is the review for test 2 and differential equations. So I'm mainly going to focus on solving the higher order linear, homogeneous, and non-homogeneous differential equations, and then the Cauchy-Euler differential equations. Okay. So the first section that you'll see, 4.1. And that was just working with the Wronskian and making sure that sets of functions were linearly independent. So from there we could form our general solutions. So for example, number 11, we have y double prime minus 2y prime plus 17y equals 0. And we're given two solutions, e to the x cosine 4x, e to the x sine 4x. So to form the Wronskian, it's a determinate sort of thing. You're going to put the solutions across the top and then take the derivatives. And you want your Wronskian to be square. So if you have three functions, it needs to be 3 by 3. If you have two functions, it needs to basically be 2 by 2. I'll leave myself a little room because I don't have to do the product rule here. All right, so the derivative of the x cosine x is just the derivative of e to the x is e to the x. I'll leave cosine 4x alone. And then plus, well, it's going to become a minus, right? So minus, because the derivative of cosine is negative sine, then leave e to the x alone. There's going to be a chain rule, so times 4, and then you have sine 4x. Okay. The other guy then, same thing, you got to do a product rule, so derivative e to the x, just e to the x. And then plus, there's going to be a chain rule there, so 4 e to the x cosine 4x. Okay? And the determinant operation is just multiply on the diagonals and subtract. Right? So you have to do that diagonal first, subtract that product. Okay? So the first product will give you e to the 2x, e to the x times e to the x. You add the exponents, so you get e to the 2x. Cosine 4x, sine 4x, and then plus 4e to the 2x, again, and then cosine squared 4x, and then minus this other thing, so that other diagonal, we have e to the 2x sine 4x, cosine 4x, minus 4e to the 2x sine squared 4x. Then you could distribute the negative and do some cancellation probably. You want to simplify this, don't just jump to the conclusion. So it looks like this guy and this guy will cancel each other, leaving us with a sum of squares. We can factor 4e to the 2x out of those last two terms, these guys. And then you're left with a cosine squared 4x plus sine squared 4x, which we all know from the Pythagorean identities is equal to 1. So we just end up with 4e to the 2x. I'll have to also give you some sort of interval on this one. I presume it is negative infinity to infinity. So on that interval, that function will never equal 0, and that implies it's linearly independent. Okay, so basically all I have to do is does not equal 0, and then write up your general solution. Okay, so y will equal, just take the two functions and slap some constants in front of them. C1 e to the x cosine 4x plus C2 e to the x sine 4x. And you're done. Okay. All right, so that's 4.1 stuff. Just go in there and make sure you can handle the Wronskians in that exercise set that I listed. The next section then, 4.3, dealing with homogeneous linear differential equations with constant coefficients. I promise not to put any higher order ones where you need to kind of have like a method for factoring with the synthetic division. I won't put those on the test. Those are mainly just in the homework, the hard ones. But I'll do one here in our examples just to, in case you weren't sort of able to figure them out. But I promise on the test, I think most of them were second order. So anyways, let's take a look at this guy. 2 is 0. So you want to form your auxiliary equation, sometimes called the characteristic equation. It should be at D23. So m cubed plus m squared minus 2 is 0. And this thing you got to factor, right? So you can do synthetic division. Usually I just look at it and kind of guess. So if I put 1 in for m, I'm pretty sure it's going to be a solution. But I still need to be able to factor this thing, right? So that's where I would use synthetic division. 1m cubed, 1m squared, 0m, negative 2. So bring down the 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. This would be a 0. This is for 0m's. 0 plus 2 is 2. 1 times 2 is 2. Negative 2 plus 2 is 0. So that gives you sort of your next version, right? So based off these coefficients, you can write down the remainder of the polynomial after you divide it by m minus 1. So it'd be m squared plus, those are just coefficients on this polynomial, 2m plus 2 is 0. Okay. Unfortunately, then, we're not going to be able to factor this guy, so you got to go to the quadratic formula. So you should have the quadratic formula memorized for the test. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which would give you negative 2 plus or minus 4 minus 8 is negative 8. So that would be 2 root 2i. And then that's all over 2. And then you could simplify that, and you're just going to get negative 1 plus or minus actually, sorry, I made a mistake. This is not 8. 4 minus 8 is negative 4, so it's just going to be plus or minus 2i. Sorry about that. So it'd be negative 1 plus or minus 1i, once I simplified by butterflying there. And those would be my roots. There's 3 of them, right? So there's m equals 1, and then negative 1 plus I, negative 1 minus I, but we just say negative 1 plus or minus I, and write those as cosines and sines. Right, so you need to then write up your solution. Y would equal, C1 e to the x plus c, whoops, then we need an exponential. So you have to have all those forms memorized. E to the negative x times C2 cosine of x plus C3 sine of x. All right, let's look at another one where it's kind of more difficult. Number 13. We have 16, then times the 4th derivative of y with respect to x, plus 48 times the 2nd derivative of y with respect to x, plus 36, y equals 0. Formula auxiliary equation, and then factor this guy. So looks like I can pull out a 4. Let's make it a little easier on ourselves. And then that looks like a perfect square trinomial, or in this case a perfect 4th trinomial. So 2m squared plus 3 times 2m squared plus 3. So you're going to have a repeated imaginary root. Anyways, 2m squared equals negative 3. Then m squared equals negative 3 halves. Then m equals plus or minus square root of 3 halves I. Let's rationalize. So plus or minus root 6 all over 2i. Repeated, right? So the roots of the auxiliary are going to be plus minus root 6 all over 2i plus minus root 6 all over 2i. So remember, when you're repeating roots for these linear homogeneous with constant coefficients, you just kind of tack on an x as you repeat. So Our solution, our general solutions here, C1 cosine root 6 over 2x plus C2 sine of root 6 over 2x, and then you start tacking on x's. So all this junk is inside sine, all that junk's inside cosine. Then C3x cosine root 6 all over 2x plus C4x sine root 6 all over 2x. Okay. Okay, so you got to have all those forms memorized. You got to know what to do when stuff is being repeated. And again, I promise not to put anyone on there where you have to do like some weird synthetic division stuff. I'll try to keep them all second order if I can. Okay, 4.5 then. We move to non-homogeneous differential equation with the annihilator approach. So problems like 1 to 21. So I'll be focusing in on the more, the doable ones. I don't want you spending an hour on one problem. So that right-hand side, I probably won't have anything all that difficult to make for you to do. Anyways, let's look at number 16, y double prime minus y prime minus 20y equals e to the 5x. So first you get your homogeneous solution, the complementary solution. So you get m squared plus m minus 20 is 0. So this would be m plus 5 and minus 4 equals 0. So the complementary part is going to be c1 e to negative 5x plus c2 e to the 4x based off the roots. Then you work with the annihilators to form kind of a new differential equation. So we already have the d plus 5 and the d minus 4 from the homogeneous part. Then you have to tack on d plus 5 to annihilate this e to the 5x. Okay, once you do that and apply that to y, that will equal 0. You can then form your auxiliary straight from here. So simply enough, it's m plus 5 times m plus 5 times m minus 4 equals 0. So your roots, negative 5 repeated, and then 4. So the solution to that differential equation is c1 e to negative 5x plus c2x e to the negative 5x plus c3 e to the 4x. Then identify the particular part, which is everything except the complementary part. The two other parts are the complementary part of the solution. This part here is this and this. So our particular part then is just that C2. Let's rename it A x e to the negative 5x. Then you take this thing and you find its second derivative and its first derivative and plug it all into the original differential equation and solve for the coefficients. Okay, in this case we just have one coefficient. But anyways, yp prime is got to do a product rule, so ae to the negative 5x taking the derivative of x, and then minus 5ax e to the negative 5x taking the derivative of e to the negative 5x is e to the negative 5x times negative 5. Then second derivative, the derivative of the first part is negative 5a e to negative 5x. Then the derivative of the second part, negative 5a e to negative 5x. And then plus 25a x e to negative 5x. You can simplify that, of course. Did I screw up somewhere? Seems like I did. Oh, I copied the problem down wrong. Let's make this a plus, so it's like number 16. I apologize. See, you could see I accidentally put a plus instead of a minus there. But if I just pretend the original problem was a plus, we'll be okay. All right. So once you're there, then you just, well, let's simplify this a little bit, right? So negative 10a e to negative 5x plus 25ax e to negative 5x. Then we're plopping all these derivatives and junk back into the original differential equation and solving for the coefficient a. So I have them y double prime, which is negative 10a e to negative 5x plus 25a x e to negative 5x. plus y prime plus a e to negative 5x minus 5a x e to negative 5x minus 20 times y, so minus 20a x e to negative 5x, and supposedly this all equals e to the 5x. Okay? Combine like terms on the left here, so I have negative 10 of those plus 1 of those is negative 9 of those. And then 25 of these minus 25 of them is 0 of them. So e to the 5x. So equating then coefficients, you get negative 9a equals 1, so a equals negative 1/9. And then finally back subbing for our solution. The solution is the complementary part plus the particular part. So it's c1 e to negative 5x plus c2 e to the 4x plus our particular solution, which is right here with a negative 1/9 in front. Let me erase that so we put a minus sign. So negative 1/9 x e to negative 5x. Okay. All right, let's look at number 19. This one is, I wouldn't put one like this on the test because the derivatives get out of control. Y double prime minus 2y prime. I'm too nice to put something like this on the test. Give me another 10 years of teaching, I bet I'll start getting a lot meaner. I hope not. Anyways, m squared minus 2m plus 37 equals 0. Okay. We can't factor that, so I'm gonna have to go to the quadratic. So m equals negative 2. This is 2 plus or minus the square root of b squared. 4 minus 4 times a times c all over 2 times a. Simplifying 2 plus or minus 4 minus 4 times 37 is negative 144. Square root of negative 144 is 12i over 2. So this will be 1 plus or minus 6i. And then I'm going to form my complementary part of my solution. That will be e to the x times c1 cosine of 6x plus c2 sine of 6x. Then I'm going to get my use the annihilator to reform the differential equation as a homogeneous differential equation. So that would be, so what do you need? Well, you have this d squared minus 2d plus 37 acting on y. And then to get rid of the e to the x sine x, you need roots m equals 1 plus or minus I. So that's going to be d minus 1 plus I, and then times d minus 1 minus I. The truth is, you don't really have to worry too much about this formation unless you have repeated roots. Here, the roots aren't repeated. One is 1 plus or minus I, the other one is 1 plus or minus 6i. So it's not going to be an issue. Your particular solution is just going to be from these roots here. But I'll write out what the solution should be. So it's going to be c1, or sorry, e to the x. From these roots, you're going to get e to the x times c1 cosine x plus c2 sine x. And then from these roots, you get plus e to the x times c3 cosine 6x plus c4 sine 6x. And you see the complementary part is sitting right here. So this turns out to be your particular part. Okay. Okay, so yp is, and let's distribute the e to the x. I'm going to replace the c1 and c2 with a and b. So I have a e to the x cosine x plus b e to the x sine x. And then I need to get the two derivatives. So y prime, you got to do product rules on both of these. So a e to the x cosine x minus a e to the x sine x plus b e to the x sine x plus b e to the x cosine x, and then y double prime. So now you should have 1, 2, 3, 4, 5, 6, 8 terms. So a e to the x cosine x minus ae to the x sine x on this guy, now this guy, negative ae to the x sine x, minus ae to the x cosine x. Now this guy, plus be to the x sine x, plus be to the x cosine x. And finally this guy, plus be to the x cosine x, minus be to the x sine x. Okay? Simplify the heck out of that if possible. So we have, what do we have? An ae to the x cosine x minus ae to the x cosine x. So those are gone. We have be to the x sine x minus be to the x sine x. So those are gone. And then we have 1, 2 of these. So negative 2ae to the x sine x. And then 1, 2 of those plus 2be to the x cosine x. And I think we're ready to rock and roll. Okay. All right, so now we take this particular solution stuff, all of this stuff, and plop it back into our original differential equation. So I'm going to get negative 2ae to the x sine x plus 2be to the x cosine x minus 2 of the y prime, so minus 2ae to the x cosine x plus 2ae to the x sine x minus 2be to the x sine x minus 2be to the x cosine x. Finally, plus 37 of the y's, so 37ae to the x cosine x plus 37be to the x sine x. And then that'll equal e to the x sine x. And then start combining like terms if possible. So what do we got here? Negative 2a e to the x sine x's plus 2a e to the x sine x's. Those are gone. 2b e to the x cosine x minus 2b e to the x cosine x. Those are gone. So it looks like I'm getting negative 2a e to the x cosine x plus 37a e to the x cosine x is 35a e to the x cosine x. And then negative 2 of those plus 37 of those plus 35b e to the x sine x equals e to the x sine x. Okay. That means, and then you equate coefficients, right? So 35a e to the x cosine x. Over here you have 0a e to the x, sorry, 0 e to the x cosine x's. Right, so 35a equals 0, so a is just 0. And then you have 35b e to the x sine x equals the coefficient on the 35b equals 1, right? The coefficient on the e to the x sine x on the right. So 35b equals 1, so b equals 1/35. And then you could write up your solution, right? So your solution is a complementary solution, e to the x times c1 cosine 6x plus c2 sine 6x plus 1/35. What do we find? B, e to the x sine x. Okay, so I promise not to go overkill on there. I think what, for the Wronskian, I may have done 2 of those on the test. For the linear differential equations with constant, homogeneous constant, I think maybe I put like 6 of those on the test, and then I put like 4 of these on the test. And I promise I didn't put any of the crazy ones like this one on. And then I put 4 of the Cauchy-Euler problems on there. So let's move over to the Cauchy-Euler problem. So again, you kind of have to memorize the form of the Cauchy-Euler, but the deal is, instead of tacking on an x, you're kind of tacking on an ln of x, sort of. So for when you have the imaginary solutions, you have to smush the ln of x inside the cosine and the sine functions, but everywhere else, like if you get a repeated solution, you're just tacking, instead of tacking on an x, you're tacking on an ln x. And the solutions are usually of the form cx to the m. So if it was repeated, it'd be like cx to the m plus cx to the m ln x. Anyways, you have to have those memorized, those forms memorized. So anyways, without further ado, let's look at number 3. X squared y double prime plus xy prime plus 9y is 0. So remember, your particular solutions form in these problems is x to the m. If you need to get the other, so at my point, I have them all memorized, but mx to the m minus 1, you take the first derivative, second derivative, m times m minus 1, x to the m minus 2, and then you substitute them in, so you get x squared times m minus 1 times x to the m minus 2 plus x times m times x to the m minus 1 plus 9 times x to the m. And then you're trying to form another auxiliary equation. So if you rewrite this stuff, you'll get x squared times x to the m minus 2. You add the exponents, so you just end up with x to the m. Same for there. Then you can factor out the x to the m. And you're left with the auxiliary part here. And you can kind of throw away the x to the m part, so you have m squared minus m plus 9 is 0. And the m's cancel this time, so I have m squared plus 9 is 0. So m squared is negative 9, so m is plus or minus 3i. And so our solution then, y equals, this will be the cosine and sine version, so c1 cosine of 3 ln x plus c2 sine of 3 ln x. Okay, so we got another one, so number 6. You have x squared y double prime plus 13xy prime plus 36y is 0. So I'm going to do my substitution again. So I got x squared times m minus 1 x to the m minus 2 plus 13xm times x to the m minus 1 plus 36 x to the m is 0. Rewrite stuff. Factor out the x to the m. Get rid of the x to the m, so then I have m squared minus m plus 13m plus 36 is 0. So I have m squared plus 12m plus 36 is 0. So you have m plus 6 times m plus 6. So 6 is repeated. So our roots, negative 6, negative 6. And our solution, our general solution, c1 x to the negative 6 plus c2 x to the negative 6. And then you just tack in an ln x. And you're good to go. All right, so again, just these 4 basic types of problems: Wronskians, linear, homogeneous, differential equations with constant coefficients. I promise not to do any super high order. 4.5 then, we're looking at linear differential equations, constant coefficients, non-homogeneous, and again, I promise not to put any like number 19 on there where you're doing tons of derivatives. I'm not going to do initial value problems either. Then Cauchy-Euler problems, and I'll probably have like 4 of those. So I think I have 4 of the Cauchy-Euler, 4 of the non-homogeneous, 6 of the homogeneous, and 2 of the Wronskians for like 16 problems, each question worth 5 points, so 80 points possible. Your score will be 80, your points divided by 80 times 100, and that'll be it. So no notes, nothing like that. You have all these forms kind of memorized, and yeah, that's about it. Should be pretty straightforward. Just make sure you're studying, do all your homework, etc. Okay. Thank you for watching as usual, and I'll see you next time.